Well, I'm Sujana. I'll be moderating this panel today, and we'll be discussing how do we design the transcoding workflows, the challenges we see in this infrastructure. I'll let the panel introduce themselves.
Yep. Good morning, everyone. Excited to be here with this elite set of panelists around me, as well as such a fantastic audience. Some familiar faces around here as well, and the crisp air in New York this morning. Everything all leads up to a great start and a great day. I'm Suresh Somasundaram. I'm the SVP of Software Engineering at Dish Network, primarily responsible for our media engineering workflows, ad tech, and everything that helps to bring a great live experience on your Sling TV platform.
Hi everyone, thanks for having me here today. My name is Raúl Santos. My pronouns are he and him. I'm the Senior Manager for Media Cloud Engineering and Content Tooling at Peloton. And thanks for having me here today.
Hello everyone, this is Poorna Reddy. I work as a staff software engineer at Netflix for the Media Infrastructure Platform Group. Glad to be here today to talk about the stuff that we work on.
Perfect. I think in the audience we have everyone from like fast, VOD, live streaming, everything, right? So how do you see the differences or the similarities between live streaming versus VOD?
Oh yeah. The first and foremost with live TV is you don't get a second chance, right? It's like real-time transcoding, encoding, segmenting, packaging, distributing to your origin, and then subsequently to your CDNs and to the target devices. Now, the scale kicks in when you deliver hundreds of thousands of linear TV channels at varying degrees of profiles on the bitrate ladder, and especially when you target for, at least at Sling TV today, we offer our services on 18 different platforms. Now, if you start peeling each and every platform, within that you see a lot of families of devices, generations of devices that are out there, and then you deliver it on a distributed network, full, on a variety of CDN-based platforms, the complexity starts kicking in. One thing about linear TV is another key aspect that we care for is not just the quality of the content, but even the seconds behind live, especially as it relates to sports, streaming content or news content and things like that. And delivering this on a sustained basis, on a continuous basis with very high quality. We care for a lot of metrics. The first uber metric when it comes to a transcoding workflow, especially for a linear TV platform that we care for is number of seconds and number of minutes that have been encoded successfully for various linear TV channels. And then you start peeling that to a second level metric, a third level metric, and so on and so forth. As you start peeling the layers of the onion, we care for the quality of the content finally that is rendered on those devices. So that's primarily we look at from a linear TV standpoint. We also offer on demand and a flavor of live TV, even when it comes to like catch up, look back, and so on. But when it comes to live TV, you don't get a second chance. And we got to deliver it with very high degree of quality.
Someone's mic is on, sorry. Okay, yeah. So Peloton and Netflix, both of them are doing VOD and also live at the same time, right? How do you see it in VOD actually? Like when VOD is doing things, how are they different when it compares to live? I understand the latency is a limit. Other than that, what else do you say?
I think for VOD, in our case, we're an interactive experience. So we're always collecting metrics and kind of displaying that back to our members, and you have that for live and on demand. There are certain features that we offer only on demand when it comes to what music tracks are playing or other metadata that's included. That's where we kind of differentiate. Also, in our case, a lot of our infrastructure for VOD is all cloud-based, while for live we mix of on-prem and cloud.
That's good. In case of VOD, when we talk about infrastructure, how important is latency versus the compute intensiveness? Like how does that come into play?
and again, challenges with VOD is we have so many codec available. So we have to maintain the life cycle of each codec. That means testing out each codec means going through a set of experimentation. And when we are doing these experiments in cloud, you have to go through, you have to make these instances available so that the experimentation keeps on going. That means make them non-preemptible and also provide GPU if needed, right? And once this experimentation is done, you basically then build the bitrate ladder, where that's when latency comes into picture. Until then, latency doesn't come into picture for VOD. And based on building the bitrate ladder, you kind of see what's the bandwidth of the user and what profile they are in. Based on that, you deliver the content from one of our Open Connect CDN networks. Right? That's what we do basically.
Okay. And now coming to the workflows part of it, there are different kinds of workflows. One is during the content creation versus content delivery. So in terms of content creation workflows, what kind of latest technologies are we using to build these content creation workflows these days?
So basically we run productions globally, and that's where we rely on edge systems. We sometimes do cloud-based encoding and cloud-based editorial, but for most of the globally distributed productions, it might be an edge-based setup where we only bring the dailies after the editorial is done into the cloud to the next part of the workflow, right? So that's where we rely on edge-based computing. And for cloud-based computing, basically we rely on all the workflows that we do for a different kind of encodes, and primarily it is we don't have reserved capacity for our workflows. We run something called a struff. That means when Netflix has servers available which are meant to be used for other services, we basically steal them in their downtime and use it for encoding. What that means is we need to have a big enough work queue that can keep the back pressure to start processing when a lot of compute is available. And the other challenge which comes with this is also where is the storage and where is the compute available, and how do you orchestrate so that you move or you are as efficient so that you don't move too many bits across the region, because our workflows run across regions. So that's one of the primary.
That's interesting. Now all of these comes at scale, right? Scale means different things for different systems. So what does scale mean for you, when you are doing?
Sure. So I want to touch upon the content workflow that he talked about and connect the dots from a scale standpoint. If you look at the media pipeline, the media workflow in and of itself, right? Sourcing the content, digitizing it, encoding it, segmenting, packaging, pushing it to the origin, subsequently to the CDNs, and every step along the way, it looks like a very predefined set of workflows. But the plot thickens when you look for different types of contents. Linear content, locals, that's going to be very different because you've got to source it from different local regions and then ingest it into a common pipeline and then distribute it across the board. Then you have different varying rules around it, like from a look back catch up standpoint and things like that. Now, the other aspect that we're doing some interesting experiments around this is also based on the type of the content as well. Like we can change from a very static set of bitrate profiles in the ladder to make it more variable depending upon the complexity of the scene or the nature of the content, because if it's a sports like content, there's going to be a lot of action, and you want to give the best experience for a customer from a viewing standpoint, versus when it's in the studio, when somebody's reading out a news or something, the number of changes that you see from frame to frame is going to be very less, and you could live with a smaller set of or a prescribed set of bitrate profiles in the ladder. Now, depending on the nature of the content, then you can dynamically adjust this. We can also introduce AI ops into that workflow to get feedback real time and adjust, create models as opposed to a policy-based implementation when it comes to these media workflows, and keep it very lean, nimble, and a very agile workflow. The other aspect about all of these is it's an always on workflow, in the sense like linear TV is always on. You always have customers, even a minimum number of customers or a maximum number of concurrent sessions. You're going to always have these thousands of channels being streamed always online, and running like thousands of channels across 1,000 different encoders or encoding instances, orchestrated or managed by a centralized control plane, and the ability to switch from, say, a source A to source B when you run some technical issues, things like that, then that's where the complexity starts kicking in at scale. And then now you do this on a 24/7 by 365 basis, reliability, performance, scale, latency, seconds behind live. This is where I think the workflow becomes more intense, more complicated, and you can do this only at scale with machines and machine learning techniques.
It's interesting. How do you see scale for your workflows in that sense?
Well, same as you are, we are 365, 24/7, and most of our content is actually produced out of our studios here in New York or in London. But with the overlap of time, they're just running most of the time, and an outage would be infinitely impactful, not only for the teams internally, but for our members, because it would delay content being put on the platform. So scalability in the sense and reliability are really important to us. But at the same time, we use our infrastructure not only for new content, but sometimes to improve content quality. So that same platform has to not only sustain what is coming out that's new, but burst to, hey, here's this back catalog that we're gonna re-encode. And always setting priorities and being able to do both without having any member impact is really important to us.
Yeah, that brings me back to the other point. Mistakes are expensive, especially in live streaming, or bugs are expensive, not mistakes probably. So what is your take on resiliency? What kind of mechanisms do you use to improve resiliency for these systems?
Sure. From a linear TV standpoint, like I said, like we're obsessed about metrics when it comes to those media pipeline workflows. When it comes to transcoders or with the encoding workflow, the one that we care for is number of seconds or number of minutes that have been encoded successfully. Latency, seconds behind live, offset, loudness in, loudness out, a number of metrics that we can look at. We look at like 50 plus metrics when it comes to the workflow. Now we run this into a model to look at what good looks like, what great looks like, and then try to baseline the channel or the performance, and also map it against the infrastructure that we use so that we can provide a reliable service across the board. We look at in a distributed digital world especially, and with what we're seeing advancements in the digital platform world with open telemetry and so on. We are obsessed about observability. We look at metrics, we look at logs, we look at traces, we look at events and drive models, either supervised, semi-supervised, or unsupervised. But finally, it all boils down to a final set of policies how we want to manage every encoding instance and give a best-in-class experience for our customers. When it comes to viewership on several different platforms, devices, on different broadband networks or wireless networks or Wi-Fi based networks, there's just so many things that comes into the viewing experience. But when it comes to the transcoding workflow, we have a set of metrics that we're so obsessed about.
It's interesting. Searchlink TV, we have all the TV streaming your metrics live all the time.
Oh, yeah.
Pretty much. That's cool. So speaking about open telemetry, when it comes to video on demand, what kind of metrics or what kind of resilient mechanisms that would basically be important for VOD?
Yeah, for VOD, basically the experience for the media engineer needs to be as similar in the developing setup as we run in the cloud. The serverless media functions with abstractions can be exercised locally so that the same experience can be experienced also in the cloud. So what that means is you have the ability to build retries in the workflow so that you can categorize errors. Sometimes it is a codec error And how do you categorize these errors becomes very vital, so that you can catch all these errors early in the workflow and then do a replay by doing a checkpoint at that point of time. We have and allow users to set up their own alerts. There are infrastructure when orchestration and scheduling fails is one kind of an error, and when actually the media function that's processing work also fails is another kind of error. So media engineers can get insights into where exactly the workflows are failing, and then able to retry and resume from that point of time also means you are efficiently maintaining the farm instead of rebooting everything, right? So that's what we do.
It sounds interesting. With open telemetry, especially for the video kind of workflows at scale, it is expensive in terms of storage, in terms of streaming them, in terms of aggregating them in every sense. So how are we maintaining the cost related to it? This is a question not just for like in the video world, but everyone today is becoming the victim of open telemetry, crossing budgets. So how are you keeping checks for it?
Yeah, a number of factors come into play. So essentially there are just 4 options out there. You run your encoders either on bare metal or on a virtualized infrastructure or on containerized. All 3 flavors are available out there, either built by the streaming companies or offered by platform providers, or the 4th variant is you look at a hybrid based option in a public or a private cloud instance or a hybrid cloud based instance. A lot of factors goes into choosing your infrastructure. First and foremost, it's like where the content is available, how you source your content in a more efficient and in a very effective way, because you don't want to transport the content left to right and introduce seconds behind live overall into your distribution workflow. And sourcing these content, aggregating it in a centralized state, and operating it in a more resilient fashion. Redundancy comes into play, a lot of other aspects. When it comes to the observability and metrics, we look at all of these are like state and time, especially when it comes to linear content. As long as we're able to feed the data, quickly take actions on those metrics, and provide a reliable service as it relates to the encoders, we don't need to store the data for a longer period of time other than collect the insights at a varying level, like what does the 99th percentile look like on a 30-day period versus, say for example, on a top 10 channel or a top 100 channels and so on. So we don't need to store all of this data per se. We just want to be smart about how long we store and what insights we gain. That's the key thing that we want to keep tabs on.
That's interesting. And at Peloton, you do the interactive views for the user. So there's a video, that's a live video that's playing, and then there is the interactive dashboards that you're showing. So how do you keep them in sync, like when it comes to the synchronicity for these segments?
There's a lot of internal contracts of how much latency we introduce into that video versus our data pipelines that don't follow that traditional media data pipelines and are more custom built to make that magic of the Peloton experience.
It sounds good. So in terms of interactive content, I know Netflix does some interactive content, did interactive content. How does this transfer to infrastructure? The interactive content is generally large. So like what does that mean for infrastructure and the challenges it poses on it?
Yeah, it's basically metadata, right? So all of this can be categorized as different set of metadata. One being the title metadata, which basically allows us to categorize the content or the category that's displayed on the site. And the other one is the content metadata, which we basically use for encoding the quality metrics, and also for short optimization, we use the short-based metrics. And the third one, is the content insight. So after doing all of the encoding, you also go and do a lot of machine learning algorithms to figure out what's happening in the scene, so that on the website we can give a preview of what's happening, cater to a particular user. Right? The same preview might not run to another user. And the next step is where we have continue to the next episode. That's one kind of metadata which is done as a part of insertion when we are encoding to see when the user can continue to the next part, next episode, and also point of interest, where can we do ads and all of that. So those are the different kinds of metadata which are annotated on the content. And we use different kind of systems to store and serve this metadata, and some of this is available hot on the service, and some of this is only available for analysis in the background to generate creatives based on the content.
Okay, that brings to the ads and the very innovative space that's happening in ads. So how do you see ad insertion or like the other innovation that's happening in ads, especially with the live streaming? How is the atmosphere changing from static ads to dynamic ads to now inserting at like point-based ads, right? Like how is it working?
So pretty much the industry has evolved and matured itself in terms of adopting a server-side ad insertion technique. Pretty much everybody does that today. And dynamic ad insertion is also pretty prevalent because it gives you a very high degree of ability to target, serve ads dynamically in a matter of few seconds or sub-second, based on the customer's profile, their watching history, and the profile of the customer per se. Now the ability again to serve billions of ad transactions on a large scale basis across a linear TV platform requires scale, and also having ability to access to the data and run your models or run your algorithms real time to serve those ads on a real time basis. Because the ability to insert the ads is also critical. It's got to be a very graceful experience in the sense that there should be a very clear transition from a linear feed to an ad that gets served and back to the linear feed. And especially when you're watching content like sports, you don't want an ad overlapping over a sport content and things like that. So it's the margin for error again there is very minimal. Now delivering this across millions of devices, across several hundred of thousands of channels, talks about scale, talks about performance, talks about the ability to also manage against the inventory that you have. Especially in the ad world, we are very curious about metrics such as the fill rate, the use rate, and the inventory, and the ability to pace and serve your ads very well so that you can place the right ads for the right customer at the right time, on the right platform, on the right channel, involves a lot of precision and lots of logic on the fly. He was talking about metadata in the context of serving for customers, for them to help make some intelligent viewing, purchasing decisions or watching decisions when it comes to content. There is a whole set of metadata that happens behind the scene that is not directly relevant to the customer experience from a UI UX standpoint, but more importantly, like, how do you drive the best experience for the customer when they're watching the linear content? We want the ad experience to be more graceful and not be sort of like an overload.
It's interesting. In terms of metadata for ads, there's one way to do it, like collecting manually, the users tagging the metadata for your movies or your content. But there's also an engineering way also to generate metadata. Do you, any of you or your teams work on generating metadata from the content itself and then use it for personalization? Do you see that an interesting challenge that where industry is heading?
So you're leading us more to what sort of like the Waze app experience is, right? Like, you're driving, you use a map to get to your target destination, but along the way, you also source content from customers like, is there a cop around the corner? Is there a camera around the corner? Is there a stoplight? What does the traffic look like? Is there an accident around the corner? So you collect all this intelligent information and feedbacks as a community-led information that serves the community back. They can make, they can take a route A versus route B. In a very similar way, we also see that element of interactivity coming in the television world. Very simple things like a thumbs up versus thumbs down versus what customers like. There is also the context that matters. If I go to my search today and search for Formula One, I want to watch the Grand Prix that happens this weekend. I don't want some Grand Prix that was a highlight, like that was recorded 2 weeks ago, or something that's going to come about a month later. So the time, the situation, the context to a particular keyword or a metadata also matters. So the ability to, and that's where I think the metadata and the context matters a lot, and interactivity comes in, from what customers like versus don't like, whether they want a reminder, whether you want to record, things like that. A lot of things comes into play.
That's interesting. In Peloton, in order to recommend the kinds of workouts the users would want to do, what kind of metadata or how what kind is something that I would not ask, sorry. How would you actually deal with the metadata, and how are you generating it and using it for your recommendations?
So I can't really comment. My team doesn't really work on that platform. There is a personalization team that does focus on recommending what's best for you, what's recommending things like a post-class stretch after taking a cycling class, or stretching after a running class. So there is a personalization team just focused on that.
That's cool. My dream is like when the movie plays, the scene doesn't change, but the ad just blends into it, right? Today I see a movie, and then a flashy color comes and an ad comes, and I change the channel. Instead, I want to be part of the movie. So, yep, if you're aiming for ads, anyone starting a new business, that's the way. So let's discuss a little more about edge computing, right? Now that the content that's getting generated today is crazy high, from mobile devices to the content that's getting produced somewhere in Maldives or somewhere. Right? How do you see the future of edge computing, and how do you see the seamlessness of moving from edge to cloud?
Yeah. So like I alluded before, like we have productions that when you have productions globally distributed, we cannot get everything to the cloud. It's not an optimal way of making your workflows run. So basically, providing the same experience of having this cloud infrastructure run on the edge in a smaller scale, and allowing users to exercise the same telemetry and media functions there, gives you a reusable setup, which is kind of helpful, so that you are not building two diverse products for edge and for cloud, and you usually kind of also bringing in the asset at a later point of time into the cloud to make future workflows is what we have been seeing, rather than, so this is more cost efficient rather than doing everyday uploads to the cloud and then transcoding. So
there are some non-traditional, non-media kind of app experiences. Like if you look at your Ring app, or if you look at your globally local apps like the Yelp that you look for to look for your favorite restaurant in a particular zip code or in a particular city or a region and things like that. And when you look for those reviews, you don't want all those content stored in a centralized storage. You could operate in sort of like a edge-based architecture implementation. It reduces the round trip, it reduces the latency, especially when it comes to like an app like a Ring. The moment you press the Ring button on the front side of your home, you want the video to open up on your phone or your IP-based device in a matter of few seconds, and you want to quickly know who's in front of your home, because you got to beat the experience of an analog Ring device, where there are such use cases where these edge-based, low latency, requirements-driven use cases have a ton of value.
That's good insight. We're at half time. I would want to know if anyone in the audience has questions. We could take them now, and then I'll give another chance at the end of the session too. Yes.
So when you make these ad insertion decisions, do you make them all at one time, so that this viewer is going to watch this show? There's going to be 3 breaks, and then you make an ad decision for all 3 breaks, or?
It's dynamic, it's real time.
So to repeat the question, it's basically for the ad insertion, is it going to happen at once for the user, or is it going to be dynamic? So that's the question.
Because the nature of that is because your inventory is changing. It depends on which channel the customer is tuned to. It depends on which device is he or she watching. A lot of characteristics define the decision-making process. The chances of us making a systemic decision early on might just become a hit or miss. That's where I think we scale with machine learning-based techniques, especially when it comes to ad decision making. And it was also discussed in the previous panel too, where I believe our colleagues at Disney were talking about the scale at which they were delivering ad decisions for their Disney customers.
Yeah, that's what I was wondering about. In order to minimize the number of decisions, you try to group the decisions so you could minimize the CPU that's required to make those decisions.
Yeah. But you got to also balance that with metrics such as are you targeting the right ad for the right customer and getting the bang for the CPM from an ad revenue standpoint. So it's a good balance between performance at the CPU level versus the yield versus the efficiencies versus making sure that there's a lot of factors that goes into you don't want a repeat of a Chick-fil-A ad followed by another Chick-fil-A ad. So things like that. We also got to space it apart too. So frequencies come into place, lots of other aspects.
I see another hand. Yes.
Are you always able to fill all the ad slots that you have in live stream? And if not, what behavior is what is doing that?
Sorry, could you repeat that?
Are you always able to fill all the ads that you have to fulfill the slot? And if not, what behavior is providing?
If not,
I can repeat the question for everyone. So basically the question is, are you able to fill all the spots for your ads? And if not, what is the behavior that's expected?
It's pretty common experience in the industry to fill ads, but if we run out of that, then we tend to go for default ads or go back to the underlying content. But the most important part here is a graceful viewership experience.
So ad slot duration doesn't change. Your live stream, ad slot will still change and continue as it is for all.
Yeah.
Yes. Go ahead. Yeah.
From you, Sujana, about your vision of the ads. I had a similar question that when the ads are getting inserted in the decision making, do you have ability to decide which kind of ad really is appropriate for that particular content? Like for example, the Chick-fil-A ad may not be suitable for a particular content. Do you have a logic way to do that?
Yeah. So there are logic based on the viewership profile, based on the number of times you've served the ad versus the timing, things like that. There's a lot of there's a lot of data that drives into the algorithms when it comes to those ad decision making.
Yes. Go ahead.
Does the user platform have any impact or bearing on the ads that are delivered? For example, somebody watching piece of content on a TV versus like on their mobile device, and kind of as a follow-on, since you mentioned algorithms, are there AI-based engines back there that are also, creating or determining what's being delivered?
Yeah.
So the question is basically, are the ads different based upon the devices you see? Is the follow-on. The initial question was, I'm sorry. What was it? Can you repeat your first question?
Right. You got the first part about
Okay.
the platforms being having a
Oh.
bearing. The second part was what kind of AI is being used, or not detailed right there. But
Yeah, if AI is being used to basically decide what kind of ad to play on each device, yeah.
Yeah, so to answer to both the questions, yes, we can serve ads based on the targeted devices. And it's all rules that you can manage when it comes to those ad decisioning or ad delivery techniques. And the second aspect is the AI. The AI aspect, obviously, to deliver billions of ad impressions on a large scale basis for several thousand channels, you need machine learning based techniques. And we have to make all these decisions real time of the order of few seconds in order to insert the ads at the right place at the right time to get the best experience, and also from an ad efficiency and effectiveness standpoint. Things that we care for is, not just for placing ads, but even the frequency between ads and things like that. So to do that at scale, obviously we need AI-based techniques.
And to add on to that, another thing that changes is if you're watching the content on mobile, that means your location comes into play. Whereas you're watching on a device that is at home, that means it's static, it's IP based. In this, the context is different. You have got a location so that you can serve more context-aware ads according to the location you are located in. Right? So that's one more thing in play.
And device also plays a role, especially because of the user's ability to purchase. Like with the mobile, it's definitely higher. So it's another thing. I'm going to take one last question, and then I'm going to shift it to the end. Okay? Yes, go ahead.
So for real-time streaming, I would think live sports is one of the biggest types of content for that. How are you incorporating real-time betting into the platform during the live sporting event?
So the ability to interact with the player real time, very simple things like you like versus dislike is as good as the interactivity that you enable when it comes to the sports betting experience too. So today on our platform we do not offer that, but I know of other platforms that provide such service. But you also look at like television-based commerce, for example. There's a 15-second ad that gets played, and in that 15 seconds, you can click on a button to get a coupon or even purchase the product or get more information about the product. All of these, the foundational aspect is the ability to interact with the player, transact the data to the backend, drive a decision-making process, and give the outcome or the decision to the customer on the player as a viewing experience. Now, betting is just one form of that interactivity, if you will, or it has multiple steps in that interactivity chain, if you will. Today with blazing internet speeds, high-end devices like the Rokus and the Fire TVs and the Apple TVs and other devices, where you have some robust experience that are available, the evolution that has happened on the player technology side, and the ability to abstract all of this experience and provide all of this decision making in the cloud on a microservice like architecture and provide this real time to a particular customer at scale has allowed that real time interactivity to happen. And especially when it comes to betting and things like that, some key metrics that we care for and that we should be obsessed about, like I said earlier, is the seconds behind live, because you want to have a very good cadence when it comes to having consistency in delivering the content on all the devices, on a consistent basis.
Okay, I'll take the remaining questions till last. Thank you. So the next thing that I found interesting is, like I said, study found 65% of the internet is videos. It's basically video streaming, right? So what could be done in terms of improving the efficiency? Because we are utilizing so much power, 65% is not small, right? So what are the trends that we are seeing, and what is the innovations that are happening which are increasing the efficiency of video delivery, video encoding, video delivery? Poorna, you could take the encoding part.
Basically, in the cloud, when you have millions of CPU hours accessible to encode based on when you are encoding, when the other services are sleeping, that's what we do. So then what becomes really important is how fast you can schedule, how fast you can predict. As of now, it's a reactive process where you look at how much work needs to be done and how much compute is available in an encoding farm, and then you just go deploy it, right? That's how it works now. But future, what I feel is like there is always a trend. There are heuristics based on which you can see how your farm is behaving, at what point of time you have work pressures and what point of time you have compute available. So using that, what you can do is you can be proactive and deploy the warm containers. Because the biggest problem with all the workloads that run in cloud is cold start, right? With cold start, you spend a good amount of time to start processing messages. when I say messages, messages in the workflow which correlate to a part of a encoding or transcoding process, right? So then once you learn based on the previous orchestration or encoding, scheduling, what you do is you leverage that particular machine learning model to be proactive to deploy containers even before the work becomes available. So that kind of increases the efficiency. That's one part. And the other part is we always have containers or cloud availability in multiple regions, right? Schedulers and orchestrator needs to be intelligent enough to understand how much compute is available and what is required to process a particular workflow so that you can process everything in one region and thus reduce the transfer latency and the cost associated with it, right? So becoming optimized and becoming efficient, which in turn also means you are improving on time and also reducing on cost.
It's interesting. So Raul, in terms of the storage needs, right? Like along with this, it also comes the storage needs. How do you see that the storage needs could be reduced? And also, if you can touch base upon any of the codec efficiencies that are happening these days that can improve the overall bandwidth.
I can give a high level of this, kind of not on what we're doing, but in a general sense. I think there's a couple things. If you look at industry, there are codec efficiencies and new codecs like AB1 that are actually on the horizon, and even the latest iPhone has hardware decoding on it. So there are promises of higher efficiency in coding to help reduce that storage cost that are very interesting. And from a personal view, the technology is moving faster than I think the industry expected. The past 5 years of AB1 is probably where I would have expected to see it in 10 years. So that's a good trend for technology, especially as consumers kind of switch devices more often instead of keeping them around longer. I think Suresh put one good thing here about encoding. You can always look at encoding based for the use case. What are your needs for higher bit rate for larger motion? Where can you improve instead of having the same encoding for all your content exactly the same? Where do you need more data? Where do you need less data to be more efficient? In the case, it's a benefit for storage for all the companies, but it's actually a benefit for the members because their bandwidth cost is actually lower and they get a better experience at the end.
That's interesting.
Even a very simple upgrade from a H264 to H265 with the HEVC, you get like 30-40% efficiencies in terms of giving almost better quality experience, but at the same time with a very lighter payload, if you will. So that's definitely out there. Some quick wins and easy opportunities for us as media engineering professionals that we can take advantage of. But the other aspects is, what other new techniques that we can evolve. I see Vision Euler here, like they've done some keen investigations and research in that space of what's happening with content-aware encoding is another aspect. There's a lot of evolution that is happening in that space too.
Do you see any hardware that is changing that may help with like more efficient encoding? Do you see the hardware trends also moving that way?
You want to take that for hardware trends?
Available, and again, in cloud you have newer metal instances available. So that opens up new array of things what you can do, and availability of GPU on cloud. So that allows you to do stuff which is otherwise really difficult to do on non-cloud. So we are seeing like workflows being used after the encoding is done to leverage a lot of the metal and GPUs. So that's the advantage we are seeing with that.
See, that makes sense in a VOD-based workflow where you can gauge against the incoming volume of content, volume of assets, movies, and libraries in your library against your available CPU capacity, compute infrastructure. But when it comes to linear, it's a whole different game.
So in linear, especially the burst, because it has to be always up and running, how do you manage the burst cycles? Like the viewership burst, you cannot keep all your inflow always up and running at that scale. So
It is probably not tied to the number of viewers per se, in the sense, because you have that abstraction at the first level with CDN and the multi-level origin protection that you have today. At the end of the day, we generate the content, we provide it in multiple formats on that bitrate profile ladder, and it's up for the CDN to distribute to those customers. So it's really not a direct equation from a number of devices, concurrent devices or subscriber standpoint, but it's all about, like, we have, say, 100 or 1,000 channels. How do we deliver that efficiently for different profiles in the bitrate ladder?
that's good. So then moving on to AI, ML, the buzzwords that's happening everywhere, how does that associate that to media engineering? Like, what are the trends that we are seeing where AI is being used in terms of workflows or in terms of delivery, personalization? So
couple of aspects. One is, like I said, in live TV, there is no second chance. Especially when it comes to sports and other similar such content, you want to give the best experience possible. So when it comes to those transcoding or the encoding workflows, we got to be super obsessed about those core metrics, and we want to bring in AI ops from the ability to predict and provide a very high level of performance, reliability that we want to see for our customers, and have the right level of observability and automated decision making in the workflow, so that we can switch content to a different source if there is a problem with the source feed, or if there is a problem with the CDN, pivot to a different CDN, make those choices real time and not wait for the impact to happen. So AI ops is a big part of that, the AI bandwagon that we're looking at, because we just have access to so much amount of data and metrics that we can make all these decisions real time. The second thing is contextual based is another aspect that we are looking at, especially if you look at purely from a transcoding workflow standpoint.
Anything that Peloton and Netflix working on?
Yeah, I think for especially running workflows in the cloud, the resource usage, right? You can always apply ML and AI models to how a particular encodes workflow goes through, and learn from it and optimize the resources being used. So that's how also it affects the reduction in carbon footprint as well, if you want to take it forward. So setting it statically about how much resources are required to complete a particular workflow is one, and then learning continuously from what is the CPU and memory usage to get into the details of the resources, and then apply that fine tuning while the workflow itself is running. That also is the trend that what we have been seeing.
Fantastic. So speaking of reducing carbon footprint, is there anything that you would want to share that the industry should be doing such that we reduce the carbon footprint, especially for all the video related work?
Yeah, containers always have been subject to cold starts, right? So how fast we can start the containers is the amount of time also you reduce starting the software or the encoder on the container. So also using mechanics or mechanisms to reduce the startup time, and also have heuristics into understanding where a lot of time is being spent on transferring the bits, helps reduce the carbon footprint. Like the example I alluded before about how can we do smart scheduling. In turn, you are also reducing a lot of carbon footprint by making an intelligent decision about where, so that the compute is utilized to the optimal rather than waiting on the streams to be transferred to the other region. So this basically is also reducing the carbon footprint.
Doing more with less too, in the sense like utilizing, say for example, HEVC-based technique where you can deliver better content quality with reduced overload, things like that too. Right? You can package more channels per se on an encoder instance if that's possible too, and that gives back again to that carbon footprint thing.
And to also educate the users of the encoding workflows in cloud, having a mechanism to associate a cost with the encode, when it's infrastructure cost, also helps the media engineers to understand what is the cost associated this particular encode for this particular variant of a stream. And that gives insights and a cycle where they can go back and repeat it with optimal coding of the algorithm, right? So insights and reporting is also vital to help reduce the carbon footprint. Without having that and just using the farm as is would just not be useful.
So you spoke about the quality metrics. This is the last thing that I want to ask. What quality metrics do you observe when you're choosing between codecs?
Obviously, we follow the VMAF-based techniques where we look for perceptual video quality score, the MOS score, the viewing experience score, the technical metrics that relates to the encoder performance, that all adds up to the viewing experience. Lots of other aspects.
Is there anything else you want to add, Raúl, for the video quality?
I think part of the viewing experience is not only looking at video quality, but also looking at in our case, we call them members. In other cases, some you might call them customers. Looking at the quality of experience of their playback is vital. If you do all this back-end work on infrastructure, back-end work on encoding and performance, but if the outcome and you're not measuring what is your customer actually, or in my case, members are actually experiencing, the value, it needs to correlate. So you want to make sure if you make changes on one end, it translates to what people are seeing at home.
Outside of the transcoding workflow, there's a lot of metrics that we care for, like video start time, video playback failures, things like that, right? That talks about, every click has to translate into a playback experience. That's what we dream, and that's what we obsess about.
That sounds good. It's great to have you speak about all these things. Now let's take the questions. I know many questions were there. Yes.
Yeah, actually, MVPD is becoming a super aggregator. Okay, they don't have live content, but they have a lot of VOD, a lot of OTT channels. So how do you manage the experience for other content which yourself are not managing?
Repeat the question.
And when you hear the question, can you just repeat it for everybody?
Sure. Could you please repeat the question?
MVPD or virtual MVPD become a super aggregator. That means you don't only own your own live content, but also own OTT content which came to your own platform. So how do you manage the quality of the content where the infrastructure you are not managing streaming infrastructure? How do you do that?
So we manage the streaming infrastructure. Let me answer. You want to repeat the question?
I didn't hear it, so if you could.
Sure. So the question here is if in the case of VMVPDs, we are super aggregators. So how do we manage the experience from a streaming infrastructure standpoint? Is that right?
Infrastructure when you yourself are not managing that streaming content. Right?
We don't own the content, but we source the content, and it is our responsibility to give a very high quality experience for our customers on their target or their favorite devices. It's all about comfort, convenience, control. You open up an app, you want to get to your content very quickly, the ability to search or the ability to recommend, it should be so easy for the customers to make their viewing decisions very quickly and get to their favorite content faster. And then there is a lot of aspects around the experience, which is basically you want to record it or go back and watch from the beginning or fast forward or things like that. Every aspect of that journey of that experience is very important. It's not just, while we don't own the content per se, but the ability to provide a best-in-class experience, and it starts all the way from search recommendations all the way to playback, and even post-playback, the ability to record and make it easy for customers to discover their content is extremely critical for us.
Check.
We good? Okay. So I'm curious from a transcoding perspective where your QA responsibility starts and ends. If you're hitting your quantitative playback quality metrics in some software player, right, that's running as an automated QA process, right? Is that where your QA responsibility ends? Or are you also actually doing real QA on various different brands of TV, mobile, and I mean, Peloton, you even own the platform end to end. So I'd be curious where your QA responsibility starts and ends.
I'll start with this one. I look at it as QA never ends. And I make my team responsible for always validating and always kind of not only looking at observability and metrics. In my case, we have key performance indicators that we not only split by region, but we also split by platform. So we're looking at that same data and slicing it in different ways to make sure that that holistic experience is equal across the board.
But if you look at the traditional digital practices that are evolving in the industry, like the ability to do an experiment, A/B test, compare key stats, metrics on different platforms, because you cannot match the scale that you get in production in a QA lab or an instance. While I'm a big advocate of that and continue to emphasize more on testing, but it's also testing the waters with say 1% of the traffic and getting some early data and then scale from there or fix things in advance from there.
What to you is good versus good enough? Because we have content in all of the platforms where the languages which are delivered to the customers are not equal across the board for all the content. So we might have one content which has got 17 languages you can stream on, and other content has only 2. So how do you make sure that what is good versus good enough?
Languages as in speaking languages? Different customers, different profiles, different backgrounds or different countries that they come from, and different languages. So it's more of a how do you package the right content for those customers? We do have a substantial international viewership based on our Sling TV platform. So we have very targeted packages for those customers, and we provide them as an add-on service on top of it, on top of our existing packages, and provide that as like a curated package. It's like a Spanish package or a DC package or things like that we provide for our customers.
Is Netflix doing something like this?
It's mostly part of the creative team, right? End of the day, like what content and how it gels with a particular language is a creative decision rather than an engineering decision about how we deploy and where we deploy it.
Do you have any plans to automatically stream based on, let's say I have a Spanish package, I purchase a Spanish package, and I can automatically stream any content in Spanish, that kind of plan?
Usually location-based type, Netflix is globally distributed. So it's all the titles that are available are basically for that particular location, and then we offload to the CDN based on the bitrate and the available bandwidth of the user, what is the most popular stream that is being used, so that we don't pressure the internet and we keep only some things in ISPs. And then coming back to it's again a language preference. If the user has switched on to a Spanish language and then popularity based on that particular region, those titles will be available, and probably they will be pushed ahead of time than any other titles, right? So that we don't bring down the internet.
And that is again an AI-based decision?
No, it is basically a feedback mechanism.
It's an implementation architecture. It's the Open Connect strategy is a win-win architecture, both for the ISP as well as for the service provider of the video services, right? You want, with an Open Connect like strategy, you get the best video quality experience from a serving standpoint, but at the same time, you also keep it very light on the broadband service network.
I think related same question.
Hi, similar question. How Gen AI going to play in terms of localization of content? Like when you're converting language from one language to another language, your content. Most of the time we see the issue of lip sync. Okay, your lip is not matching with what the content is showing it. Can Gen AI can play the role of bringing a very highly engaging experience and kind of solve the lip sync issue?
As of now, with most of our VOD content, we stayed away from AI wherever there is creative work involved. In future, probably, but now it's mostly based on creative input. It's more manual. And in future, it can change, but as of now, it's just creative based.
I think we can just take like one last question, and I think that we should be done. Oh, you're done? Perfect. Okay, thank you everyone for coming. Thank you for participating in this. This has been a great panel. Thank you.
Thank you, Sujana.
Thank you. Thank you.